Okay, class, today what we're going to be looking at is solving one-step equations, and we're going to be reviewing what we've talked about over the last couple of days. Okay, so here we go. First thing is, what is an equation? So hopefully you remember that an equation is nothing but two expressions that are equal to each other. Okay, that's all it is. And we have one goal. So what is the goal for an equation? To solve for the variable, to figure out what that letter represents. So let's just kind of review a couple things so that you can complete your assignment today. So if I give you an equation like this, first off, this says that I've got some number, and if I add 6 to it, I'm going to get negative 12. Now, most of the time, there are quite a few of these equations that, yes, you can do in your head, but you're not allowed to. You must show the work. If you don't show the work, I will take off points. So here's how we solve this. Okay, our goal is to get this letter by itself. So I need to get rid of this plus 6. And we do that by adding its opposite. So the next line, what I expect to see on any problem that you have like this, is x plus 6 plus the opposite of 6, which we know is negative 6. So these two will add to give 0. But we know that in an equation, that if I do something to one side, I must do it to the other. So what did I do to this left-hand side? I added a negative 6. So that's what I've got to add on the other side as well. So I end up with negative 12 and then plus the negative 6 that I added on this side. So now my 6's on the left-hand side, my 6 and my negative 6 actually go away. They make a 0. And I'm left with just plain old x, which is what I want. But then on the other side, I've got 12 negatives and I've got 6 negatives. So now we have to remember our integer rules. If it's addition and my signs are alike, we add the numbers together and keep the sign. So negative 12 and negative 6 gives me negative 18. Now, intelligent people take this number and we plug it back into the equation just to see if we get it right. So if I plug that back in, I would end up with negative 18 plus 6. Does that equal negative 12? And yes, it does. And that's what we're doing today, is we're just solving equations. So let's do another one real quick. On this one, we've got m minus 8 equals 4. Well, if you go back and remember what we did in class, if we have a subtraction problem, we have to do something to it. We have to change it. So what we're going to do is we're going to change this subtraction to addition and this 8 to a negative. And now we just go back and do the problem exactly like we just did the previous one. Okay, so we're going to change subtractions to addition, next numbers to their opposites, and then solve the problem. So now I've got to get rid of this negative 8. So I do that by adding its opposite. So m plus negative 8 plus positive 8. So this is the new thing, equals 4 plus positive 8. Make sure that that's on both sides. So now negative 8 and positive 8, they go away and become a 0. And I'm left with just m on the left-hand side. And now I have 4 plus 8, which gives me 12. So if I were to plug that back in to the original problem that we had up here, 12 minus 8, does that give me 4? And yes, it does. Okay, one last one real quick, and then we'll move on to multiplication and division. Okay, so what if I have the letter on the other side? Is that okay? Yes, it is perfectly fine. I'm still trying to get this letter by itself. So what I do is I start at the equal sign, and I start writing on this right-hand side. G plus 7 plus negative 7. So there's the thing I'm getting rid of. Okay, so now on the other side, I just take the 10, I write it a little further over. 10 plus, and now what did I add on the right-hand side? The negative 7. So 10 plus negative 7. Now we just do the math. On the left, 10 plus negative 7 gives me 3. Equals on the right, well, my 7's go away, and I'm left with just plain old G. So 3 equals G, or G equals 3. Now again, you take that 3, you plug it back in. 10 is equal to 3 plus 7. Is that a true statement? Yes, it is. So let's kind of review what it was that we did with addition and subtraction equations. First off, for addition, you have a goal. Your goal is to get the variable by itself. How do I do that? I add the opposite. Well, what if it's subtraction? Well, if it's subtraction, you change subtraction to addition, change the subtraction sign to an addition sign, and the next number to its opposite, and then we go back to the add rules. Okay, so that's all we got to do. We add the opposite to get rid of anything. If it's subtraction, you change subtraction to addition, next to its opposite, and then add its opposite. So what if I have a multiply problem? Well, we know in multiply and divide, what we have to do is, instead of add the opposite, we do the opposite. So in this one right here, I've got 3 x's. So in essence, I have 3 x's, and I've got 18 things, or negative 18 things, I got to divide out amongst them. Okay, so if I were to actually divide them out, I've got 18 negatives. Here's 1, 2, 3. There's 3 of them. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Move this over a little bit. 16, 17, 18. So I divided those 18 negatives among the 3 x's. And what I'm looking for is, what is 1x equal to? And you'll notice that 1x there equals negative 6, because there's 6 negatives there. Now, how do I show that mathematically? Because you must show your work. So here I have a multiply by 3. So what we learned in class was I just do a divide by 3. So if I have a multiply by 3, I do a divide by 3. If I divide this side by 3, I do the same thing to the other side. So 3 divided by 3 gives me a 1. So that gives me 1x, or just plain old x, which is what I'm looking for, equals, because I want to know about 1x, not 3 x's. So now I do the division on the other side. Negative 18 divided by 3. Well, 18 divided by 3 gives me 6. 1 negative makes it negative. So 1x equals negative 6, or just x equals negative 6. And again, if I were to plug that back in to check my answer, 3 times negative 6, does that give me negative 18? Yes, it does. So let's try another one. What if I have a division problem? Okay, the first one was a multiply, so now I have a divide. So now I already have this divide by 3. So this is the same thing as like saying 1/3 of f. 1/3 of f is equal to negative 7. So those are the same problem there. So how do I get rid of a divide by 3? I do a multiply by 3. So I put a 3 up here on the top, which is a multiply by 3. So here I had a 3 on the bottom, so I put a 3 up here beside the f, or on top, in order to get rid of it. So if I multiply this by 3, I've got to multiply this by 3 on this side. So now these 3's, this 3 on top and the 3 on bottom, will divide out and become a 1, and we're left with f, or 1f, equals, and now negative 7 times 3 gives us negative 21. So on the division problems, there's a lot less work. So if you'll notice on the multiply, I had a 3 up here beside the x, so I put a 3 down below it, underneath it. Okay, on the division problem, I already had the 3 underneath, so I had to put a 3 up here beside. Okay, so if I have a divide by, I'm going to do a multiply. If I have a multiply, I'm going to do a divide. Now, if I were to plug this number in, negative 21 divided by 3, does that give me negative 7 is my answer? And yes, it does. Okay, let's do... Well, I thought I had one more problem there, but let's kind of review. We've talked about multiply, we've talked about divide. So now, what are our rules then? Well, for multiply, divide, we have one basic rule. Right? Goal is still to get the variable by itself. So instead of add the opposite, we're going to do the opposite. So do the opposite instead of add the opposite for multiply, divide. So if I have a multiply, you're going to do a divide to get rid of it. If I have a divide, you're going to do a multiply to get rid of it. And that's how we solve one-step equations.